universalautomation.org. It's about sharing a technology, a shared runtime execution engine.
We call it a game change in the automation because we have first one technology which is based on the IEC61499, which is the standard which aims at decoupling hardware and software.
Hardware itself is becoming very, very performant in terms of processing and CPU power, and the future is more and more about software.
This approach is really a winning approach because it's very, very flexible. You develop the application once and you can reuse in each different configuration.
That's exactly what Universal Automation and 61499 enables, because it brings a new formalism for developing software, which is object-oriented in nature and which allows deployment over distributed hardware for the actual final control system. So let's say that it's a marriage made in heaven.
So if I want to make more conscious decisions based on my business data, which also come from the automation level, I need universal automation to get this data in an efficient way and with the right engineering efforts on the level when I can do and run the analytics.
Offers are available, not just from Schneider Electric with EcoStruxure Automation Expert, but also from Advantech, from Stahl, from ESA in Italy, and from other companies.
Advantech is growing really, really fast. And I believe if you want to keep on growing in the next future, you need to be able to innovate. And when I see universal automation approach, it is exactly the way of innovation we need to go with.
Most of our customers from process automation are pretty conservative, so never change a running system. But now we see a new generation coming up, what is used to new technologies, and they are open to test, to try these new functionalities. And I think most of them pretty well understand the advantages on this. I'm doing this now for 20 years, and I think over the years, this is the most exciting changes.
And from my experience, I see that in the IT, for example, there has been a big revolution. And I expect the same in automation. I don't know when it will happen. Probably it takes a little bit of time, but probably a revolution will come.
Hi everybody, good morning, good day to all of you, wherever you're based. My name is Greg Bucco and I'm the Chief Marketing Officer for universalautomation.org. Today I have the pleasure to welcome you in this new session of the UAO Goes Live. We have been through the introduction of the association, what are its goal and its mission, so feel free to watch again our videos which can be found on either our LinkedIn page or our YouTube channel. Today, I have the pleasure to welcome Megat, General Manager from the company Trisystems. And Megal will go with us through a use case that they have done, that Trisystems has done using the technology. So please give a warm welcome to Megat. Hi, Megat.
Hi.
So let's jump onto your introduction to give you plenty of time to introduce us to your company and your use case.
Sure. Thank you, Greg. My name is Megat Shamsul. I'm the General Manager for Trisystems Engineering. So Trisystems is a system integrator. We've been doing system integration since 1994. We have been deploying 1131 systems since then. So we are the leading provider of products and engineering solutions specifically for oil and gas and petrochemical industry. But we have been expanding our market, not only oil and gas and petrochemical, we are looking in power and general industry as well. We offer state-of-the-art solutions to our customer, safety system, process control system, software solutions, packages, process packages, fire protection, filtration, combustion, pneumatic hydraulics. We have about 160 people in the company. 85% is engineer. Myself, is also an engineer. I'm a mechanical engineer, but I have been in doing these automations for more than 20 years. We have been doing deploy projects, I think, in our in customer references, probably hundreds. But we don't stop on delivery. We offer the after sales as well. So like maintenance and so on, and upgrade. So we have maintenance contract, we have price agreement with our customers. So with the track record of a successful project, in fact, they don't remember our customer don't remember the product that we deliver. They remember our name as the system integrator that deploy the system. So we are very committed on delivering projects and support and service the customer. We are based in Malaysia, but we want to expand, or we are currently expanding our reach out to Southeast Asia. So if you look at the map, we have here Malaysia, and then we have Indonesia, Thailand, Vietnam, Myanmar, and Philippines. So this is me. I'm the general manager for sales and marketing. So this is our key board of directors and key management. Yeah, let me go straight to the cases, the use cases. So we have deployed this system, PAC 8000, back in 2012. So it's been more than 10 years operationally. Unfortunately, this PAC 8000 have obsolescence issue. So we are being asked by our customer, so how we want to solve this obsolescence issue. And because of that, because we have a contract, so we are providing them with from the last 10 years our support, and we send our engineer to do maintenance and so on. So we make sure the system is operational and well maintained. And any issue, they can just call us. We'll send our engineers and make sure that the system uptime is there. But with this current issue with this PAC 8000, so we are proposed to upgrade this to another platform. So we have looking at solutions that can solve this issue. So we were looking at the IEC61499. And here we found we can answer these key questions that being asked to us by our customer. So the thing is that we don't want to change the cabinet. This is offshore platform. It is located remotely. It is not easy for us to access these facilities. You need to take a boat to go there. So we don't want to do a major job. So we just change the component inside the existing cabinet, recertify them because it's a hazardous area. So we need to recertify the control cabinet to zone 2. Zone 2 means that it is for suitable for hazardous area. And then we need to also maintain the similar power requirement. The system that we are providing the last 10 years only consume 300 watt. Actually, it's less than 300 watt, but 300 watt is what they gave us. The actual system running is about 160 watts. And this system is running purely using solar power and a battery system. And then with 61499, we can offer a longer lifespan to tackle the obsolescence issue and improve the total cost of ownership. So we are not obliged, or we're not fixed to one hardware provider. We can play with any hardware that comply to IEC 61499. So the same functionality that the current system running on 1131 will be running with the same function on IEC 61499. And the pilot project that we are proposing to our customer is for the smallest platform. So the platform have 7 offshore platforms. So I just show you the picture. So this is the cluster of the offshore platforms. All these 7 platform cluster have our system, and we are proposing to upgrade only this as a small platform called this G. And what we are proposing now is we're going to remove the PAC 8000 hardware and put in, right now we are choosing the Modicon M580 DPAC redundant CPU. We're going to remove the I/O, and we're going to put the back-off I/O modules integrated with IS. So if you see here, we don't have IS barrier. The I/O is integrated with IS. And here we had this Kingfisher RTU unit, and we're going to upgrade it with the Aviva EDS running on the Moxa Edge computer. So the whole system here is running at about 160 watts, low power, but it will manage to help us in the offshore process, which is quite simple. It is a wellhead platform. The wellhead platform task is to bring out oil from the platform, but the system is basically, what it does is it helps in what we call it the enhanced oil recovery. So the system will help us in terms of how much gas or how much gas we need to inject in the well to bring up more oil. So it's connected to a smart system, whereby this smart system knows how much gas you need to inject in the oil field, and to bring up more oil out from the ground. So actually, when we put the system back in 2012, by 2013 and 2014, it already payback. They already got their money back, and it already served since then. And now they feel that the life of the platform can be more extended, because they see there's more oil that they can extract from this field. Hence, the importance of the system to be what you call robust. So we can make sure that the system is we call it don't have this obsolescence issue and so on. So we can maintain the system probably another 10 years. So this is the architecture from the picture you just showed just now. This is the architecture that we propose to our customer. So we see here we have this back-off I/O to take the pressure transmitter, temperature transmitters, flow transmitters, and it goes to a switch, a managed switch. And then we have put 2 controllers, the DPAC M580. This is an engineered redundancy that we provide to this customer. And here we have a small edge computer that consumes about 4.5 watt running on Linux. This would be our, we call it the edge data store or data buffering. In case of the radio, they have problem. And this platform running on the digital DMR, digital model radio, currently we have probably 100 Mbps. When we did back in 2012, we only had 2 Mbps of internet or communication bandwidth, but they already upgraded it, so we get more bandwidth, and with this more bandwidth, we can send good data, good high fidelity data. Before this, it was, I think, the data fidelity is not that fine. But with the more bandwidth, with the more computing power that we have, we can do that. And but the problem is radio link. If it rains, it will have issues with communication. So that's why we have a local hardware here to do the data buffering. But if you see here, this yellow line is all the control network is on OPC UA. The communication with the I/O is on Modbus TCP. And the I/O is on a ring network in case of failures. But we provide a ring network to enhance the reliability of the I/O. So the system here, the cabinet, the system is here, and this is the devices connected to the system. It has hardwired as well as Modbus serial and Modbus Ethernet TCP/IP communication. We also connected to the charge controller. The charge controller is for the offshore solar system. And then from here, it goes to a radio link. The control network goes to radio link to the control DMR, which goes to the mother platform. And then we have converted it to the fiber optic. And the fiber optic here will go to the control room. The CCR is where in the what they call it, the LQ, the living quarters. And this control network will be connected to our new EWS, which we're going to put together with the IEC61499 compliance software, EcoStruxure Automation Expert. From this 7 platform, we only upgrade 1. So probably in the plan is maybe 3 years or 4 years or 5 years to upgrade all these 7 platform. But it will have, currently this platform is running on the old protocol, DNP3 protocol. So now we have a mix of OPC UA and the DNP3 protocol, which is fine. We have tested it. It works. And for the start, only 1 platform will have 61499 with OPC UA, and we need to also add the connectivity to the Pi system, the Pi or Aviva Pi system at this platform. Currently, is using the MP3 Pi interface. Now we need to add the OPC UA connector to this Pi server so that we can get the data, but also we do control as well. So we send the set point from this Pi server back to the platform, and the platform control system will open the valve for the gas injection. The system is actually how they get the set point. The system is actually communicating with somebody, or what they call it, the engineer in the customer's HQ. So the customer HQ would have an application software that they can intelligently look at the data on the that our system brings in, and they can intelligently tell or how much gas they want to inject in which particular well to get more oil. So in short, previously probably the engineer need to go to the offshore and do this calculation in offshore. So now he can sit in the office comfortably and do the simulations, and then they can just put in the numbers, and this number will come back to the offshore via this network, and the control system will able to adjust how much gas that they need to be injected in each particular well on this control system that we provided. So just a bit of the local storage that we put is it's running as a lightweight storage system. It's the Aviva Edge data store running. So we are going to use OPC UA, and it will be connected to the Pi server. And this is very lightweight. It only consumes. Will be putting in the hardware on Linux. So here we're going to put in the Moxa hardware running on Linux, I think 11, and then with the ARM processor. So in short, this is our use case. I'll be happy to take any questions from the floor.
Good. Let me have a look. If we have any questions for now. I don't see chat coming, but one question for myself is that I see that the whole system that you have is very distributed. And how do you see that the technology, especially the 61499, has it like helped you towards this this modeling of your application?
Yeah, so 649. So the IEC standard would help us in case of, let's say, so the problem statement here, sorry, let me get back to this now. The problem statement here is that we need to support the lifespan of the system to tackle obsolescence issue, right? So IEC61499 is I think the answer, because it doesn't have to be specified to what hardware that we use. And probably this is something that we will ask in case if, let's say, we don't get this DPAC M580 anymore, can I put another hardware from Stahl or Finished Contact? Yeah, it can be, because if we can have the hardware right now, doesn't matter. As long as it's certified to IEC61499.
Yeah.
So, if you see here, we have many platforms here, and as long as all the hardware is certified, and it doesn't matter. It can be like this platform can be using hardware from vendor A, this hardware vendor B, and vendor C. So doesn't matter. It will work. It definitely will work. And the application doesn't change. So I guess this is something that the customer wants. The customer wants that the system is robust and they don't have to spend more money when, let's say, some hardware obsolete.
Yes, so really this hardware and software independence to help in terms of let's say resilience, maybe of supplying of product on one side, and the other side to kind of push away the risk of end of life as we know it today. If I can
Yes.
summarize it, yeah. Yeah, that's very good, and that's what we are as universalautomation.org pushing as values for the technology that we are supplying. So it's great to see that the customer as well, the one using the technology is also seeing that. I am switching to another question, which is coming from LinkedIn, from Mudassir. Are there any bottleneck or shortcomings of the 61499? Where can it be improved? So do you have any feedback on that?
So yeah, one thing when I presented this to Schneider, this hardware here is not a product redundancy. Means that this DPAC M580 is just a single unit, but because of this platform, it's critical to have a redundant unit because it's far, it's not easy to go, and and we need to put a, a redundant system.
Yes.
So we have one thing that with 61499, I'm sure in the future they will come up with this redundancy. But currently we are doing an engineered redundancy, basically from our engineering, and we already tested it and we already demo to our customer. It works. If let's say this one controller fail, the other controller will take over, but it requires some unique integration that we
Yeah.
do. So that's one shortcoming that we face during this case, and also the IO redundancy as well. So there's kind of an engineered redundancy that we do internally to ensure that if let's say an IO card fail, we need to get another IO to take over. So yes, that's the problem, the issue that I have when I did this. So I'm sure there is in the future there is
Yeah.
a solution to this.
Yes. Yes. I mean, the technology in itself is always being improved, and new features are added to the technology, and that's the goal of the association in itself, to gather those let's say feature requests and put them into the technology so that they can grow as well step by step with the needs of the different user. Maybe one thing which maybe happened in between your use case and now is that the newest version of the technology now embarks high availability, which could have been a great help for you in your use cases. But yeah, as said, it's evolving, and it's all, let's say, features which are coming with the time and with the request from the different users.
Sure.
So, yeah,
Yeah, just to add, I mean,
yes,
there is Schneider had offered me the redundancy on the IPC,
yes,
the computer, but the issue is that my problem with this is the power. Um, I I only have 300 watts to play with.
oh yeah,
So we need to have maybe in the future the
mm-hmm.
hardware that have low power like this.
Yes, yes,
Like this total system we calculated is about 160 watts, and it works. It will work
mm.
and it will serve the purpose.
and I think that could be, in fact, a great way to make an appeal to the technology vendors. In fact, because if we have more technology vendors which have such a product on which we could deploy the technology with, for example, the high availability, so you can use it. This could be a great functionality for you, or a great opportunity.
Yes.
What do you think? Yeah.
Yes, definitely. The technology or the OEM, the vendor that can look at each use case. I'm sure if let's say it is for a gas pipeline or a remote application, even for oil and gas, where we have a diverse similar like this, where we are depending on telecommunication to link the controller together, and we are doing an application whereby we need the telecom, we need the controller, we need the IO, all that can be packaged. I'm sure there's a lot of application in the world that have a similar requirement like this.
Yeah, and that's a perfect point, because I mean, when we speak about vendors, we do not speak only about traditional, let's say, PLC vendors, but we also include, that's why we use the word more technology vendors, because we see IPCs, we see RTUs, we see managed switches, we see, in fact, a lot of products which are embedding a CPU on which the runtime could be ported onto. So that's a wide variety of product and of possibilities to embark the technology.
Sure. Like for example, this IPC only consumes 4.5 watts, and it does the work for data buffering.
Yeah, that's so. If we have some Moxa people, that's a great appeal to them to join the association, so we could port the runtime onto their platform. Good. I see we have another question coming from LinkedIn. Let me put it here from Konanda. Are you expecting the same application developed for this platform to be reused for the remaining platforms as well in the future?
Yes, because the application is similar. It's for, as mentioned, is for the they call it the EOR application. Not much change. The only thing that is fixed is the wellhead, and the sensors is the same sensors. The application probably, if we do one, it will be similar to other location as well.
Yeah.
And we can deploy it without going to the offshore platform. Let's see if I see the architecture here.
So let me just put back again your presentation. Yeah.
Yeah, you see the architecture here. You have this engineering workstation here, and we can deploy to all the other 6 platforms without having to go there. I mean, we can do the engineering and we can deploy it via the telecommunication link, and it's done. It's possible.
So we see here even an application with using wireless telecommunication in between. Huh?
Yeah.
So yeah, that's very impressive. Good. I see no other questions for now. So maybe one last question to you, Megat. What would you say to because we have seen for this application, okay, you have used Schneider Electric with for the redundancy that you did it yourself and so on. And but in general, what would you say to all the technology vendors out there which are looking for their next generation of product and maybe of automation as well? Do you have something that you want to tell them?
Yes.
Regarding the association?
So basically, we are system integrator. We build system to customer. Our customer is the end user that use for us for an application. As a system integrator, we look for the best solution, and sometimes there are some specific requirement coming from customer that we need to think and we need to look at the technology, what technology that available in the market. So, and as a system integrator, we are responsible. The sole responsibility of deploying the system to the customer is us. This is the beauty with IEC61499, because the IEC61499 very centric to system integrator, which we like. And what we want to tell to the provider of the technology is that sometimes talk to us. We probably have some ideas for the technology vendors to develop the hardware and probably the software for us to deploy more IEC 61499 systems.
Yes. Thank you for your last comment, Megat.
Yes.
We reach the end of this session of UAO Goes Live. So just to give to all our viewers just an outlook, we will have the next UAO Goes Live coming quite soon. So please stay tuned and have a look on our LinkedIn and YouTube channel to check when it will be. So here are the details. If you want to get in touch with Megat from Trisystems, if you are having any project in Southeast Asia that you want to look for a system integrator to support you in implementing the technology, please use our member, use Megat and Trisystems, and they will be happy to welcome you. Any last words, Megat?
Yeah, I would like to thank you for having this session. I appreciate the time given to me to do this presentation. I'm happy we have done this.
Yeah, thank you, Megat. Thank you for your support, and thank you to all the viewers who could make it, or maybe will watch it afterwards. And please stay tuned for the next session of UAO Goes Live. Thank you, and bye, everyone.
Bye.